The WSPR instrument is made of two telescopes that are designed to sit between the two antennae from the Fields experiment and image the solar wind and the corona as we're flying into it. So WSPR is the lightest instrument we've built before, but had really two requirements. We wanted to be able to see far from the spacecraft and then be able to track the structures that are flowing out from the sun, and then as they pass the spacecraft, we would see them locally at the spacecraft. The WSPR instrument is the only imaging instrument on the Parker Solar Probe, and it is looking in the direction that the spacecraft is traveling. And what it sees is light scattered by the dust that's in orbit about the sun. But then, once we remove that, what we see is the light scattered by the electrons in the corona, in the solar wind. These measurements that we're making from the WSPR instrument have been made before by other instruments from 1AU, from the distance of the Earth, about 100 million miles from the sun. By getting closer, we're increasing then the ability to see what's really close to the sun. The fact that you're close means that you don't have all this material that's in between you and the object that you're really interested in. And that contributes to background noise. And so you're looking at something that's much more pristine. You're looking at just that object all by itself. By going eventually 95% of the way to the sun, we are going to be able to see what is a dust-free region around the sun. That's going to be exciting. Parker Solar Probe cannot have any imager that looks at the sun directly. So the WSPR instrument looks off of the heat shield that protects us from this very intense heat. And so we sort of peek over the edge of it. We use it as a shield to block out the sun itself. And that allows us to see this very faint glow coming from the corona that's only observed during an eclipse, for example. We're creating an artificial eclipse. Well, eclipses are great, but from the data point of view, I like my instruments better. They're working continuously, round the clock, 7 days a week, 24 hours a day, 365 days a year, sometimes for years.